Ever been on a job before sunrise, generators running, diesel in the air, and concrete trucks starting to stack up? And you're thinking, do we order the right mud? Is this mix going to hold up? Did I ask all the right questions in the pre-pour meeting? And if this thing goes sideways, am I going to know what to do? That's why we built Concrete Logic Academy. It's for concrete people who want to get better at the work, not theory, not recycled conference slides, stuff you can actually use on the job. Go to concreteschool.co and get free access while it's open. Again, that's concreteschool.co.
What's the most used man-made material on Earth? I'll give you the answer. Concrete. This is the Concrete Logic Podcast. Have you ever stopped to think about the sidewalks, driveways, bridges, or the buildings around you? They're all made from concrete. So why don't we discuss it more? In each episode of Concrete Logic, we'll explore a unique concrete-related topic with the help of industry professionals shaping the trade's future. We'll talk with suppliers, contractors, architects, engineers, specialists, and even proponents of competing materials. We'll get their views on concrete and their visions for its future. So get ready to mix things up with Concrete Logic, where we turn the spotlight on the material that's everywhere but often overlooked. This is the Concrete Logic Podcast. And now, here's your host, Seth Tandit.
And welcome to another episode of the Concrete Logic Podcast. And today I have Jason Adams with Mega Slab. Jason's been on this show. This will be his third appearance. I think you were one of the first ones. I think we're back in episode 4, I think. Someone's going to double check me on that. And then again, like around 60, episode 60. So this is going to come out around, I think we're up to almost this could be like 161, 162, I think.
Nice.
So,
awesome.
Yeah. So you hopefully you're not going to wait another 100 episodes to come back on the show again.
Yeah,
but
man.
Today, Jason wanted to come on and talk about a different approach to air entrainment. So I was thinking we hadn't really done an episode that's focused on air entrainment. So the goal today would to explain what air entrainment is and what it's been used for. And Jason is going to share a different approach to air entrainment. But before we get into that, I wanted to, like I do on every episode, I want to let you all know how you can support the show. The first thing to do is if you enjoy the show or you're learning from the show or you think somebody else would enjoy the show, please share it. So share it with a colleague or a coworker out there that you believe would value the show. The next thing you can do is if you go to concretelogicpodcast.com, you can get a hold of me a couple ways. There's 2 ways. One is if you click on up at the top of the navigation bar, there's an Ask Seth option. If you click on that, email form pops up. And what you can do is fill that out. And what we're looking for is topic or guest suggestions. So a lot of our episodes are suggestions for folks that listen to the show. So that's what we're looking for, topic or guest suggestion. The other way to get a hold of me on the same homepage, if you don't want to type out your message to me, there's a microphone in the bottom right-hand corner. And you can click on that and that'll record your message right off your computer or your cell phone, whatever you're using. And again, you can make a guest or topic suggestion. So this is what the podcast is about. And we want to send out episodes you want to hear. So it's very helpful if you say, hey, I want to hear a certain topic. I want to learn about a certain topic, or hey, I want to hear from a certain guest. And then the next way that you can help out is on the same Concrete Logic Podcast homepage is there's a support button or donate button, depending on when you're listening to this. The button's been changing back and forth, but it's a big blue button on the right-hand side, and you click on that, and it goes to a PayPal page, and you can donate to the show any amount that you feel that the show gives you value. So if you feel like it's 5 or 25 or 50 or 500, whatever it is, you can give that amount, and you just fill that in, and any amount's greatly appreciated. And then the last way is if you enjoy the topics and you want to learn more and reinforce your learning in these concrete topics, check out concreteschool.co. So if you go to concreteschool.co, that is a way for you to get to the Concrete Logic Academy platform. So check that out as well. And yeah, so that's it. I think so. I think that's all I'm going to try to put you guys on today. So, Jason, let's roll into the topic. So, the first thing, let's talk about, I guess, could you explain what air entrainment is to get us kind of grounded, and then we'll take off from there?
Yeah, happy to, Seth. Thanks for having me on today. I didn't know about your concreteschool.co. I'm going to have to check that out. That's pretty interesting.
Cool. Thank you.
Yeah, pretty interesting. Yeah, so I'm Jason Adams, founder and CEO of Mega Slab, and I've enjoyed this concrete journey for quite some time, several decades now, and passionate about several topics as it comes to concrete, things I've learned, things I've explored, on my own journey. And one of them is air void structure or air void systems that are entrained or entrapped into concrete. And, the ASTM standards, right, for testing air void structures, specifically ASTM C 666, talks a lot about air void structures and how to test concrete. Basically, put air in concrete, create a bunch of air bubbles, keep it within a range, and test it. Freeze it, thaw it, hundreds of cycles, right? This is done in a specific type of laboratory setting, trying to, mimic exterior environmental conditions, very harsh environments. I would argue that some of that lab testing and the frequency that it's done is not likely to happen in nature, but I digress. It's the test, and it's the 666 test, and that's what was written, and that's what we've all followed in the industry. I'm going to stop there and say the most dangerous phrase in our language, we've always done it this way.
Yeah.
So yeah.
Let's pause there real quick. So ASTM C666, which I can't believe we have one of those.
Yep.
Someone's got a sense of humor. My understanding is that's the lab test for resistance of concrete to rapid freezing and thawing. And then we have ASTM C231, which is the field air test, right? That's the one that we see the third-party guy do, gal. It looks like a bucket, and then it's got a top, and then it's got a meter on the top of it. That's ASTM C231?
I think so. Yeah.
Okay. And then, I don't know if we'll talk about ASTM C457. That's the hardened concrete air void analysis. I think that's what you were kind of referring to.
It's more about the freeze-thaw durability.
Okay. So freeze-thaw is what we're going to focus on today.
Yep.
Okay.
Yep.
All right. So I guess, let's explain that. So air entrainment is the actual act of purposely putting, I'm going to say admixture, but that's being, I've seen guys put Dawn soap in concrete to make it happen. But what the goal is, right, is to put these tiny little air bubbles throughout the concrete to make it more resistance to the freeze-thaw changes. So temperature changes around it. And the thought is that these air bubbles are pushing out or making the concrete more dense so water doesn't get in there. Because if water's in the concrete when it's doing a freeze-thaw thing, essentially, water freezes, so it's going to expand and make the concrete crack. Is that right? Is that a right explanation, or how would you explain it?
Yeah, so the air voids that are basically installed in the cement, the paste, that's done through various means, like you mentioned, Dawn soap, a surfactant. That's typically how it's done. There's other ways to entrain air in concrete, but that's typically how it's done, is through surfactants. So basically the theory is that they're actually creating less dense concrete. Their air bubbles create less dense concrete.
Right.
So
Yep.
The theory is that water will go in, and when it goes in and it freezes, it needs a place to go. It needs a place to expand into, so it doesn't cause spalling, chipping, delamination, scaling, all the things that happen to the surface of a pavement or a slab, right? I'm gonna push back on that theory, right? I mean, this is well documented in the industry. I mean, we're not the first to create plus 7,000 psi concrete, put it outside, not entrain air into it, and it not have an issue after 4 years of steel track abuse in the Midwest with de-icing salts, brines, all those things. So you got to make really dense concrete, but putting air in it makes it less dense. So it's this conundrum. And again, it goes back to the phrase, we've always done it this way. I can't stand that phrase. Never liked it. Right.
Yeah. Well, there's different. Yeah. So just a background. I told you before we hit record incorrectly. I want to correct at least between you and I. So air entrainment was introduced to the concrete industry in the 1930s. It was discovered in the 1930s, and I guess in the 40s they were trying to use it, and then in the 50s it was becoming more accepted in pavement and bridges and exterior concrete. And then I was sharing with you, I'm reading this concrete manual from 1963. So by the time this thing was published, it was a well-known practice, I guess. So the air entrainment's been around for quite some time, over almost 100 years, I would say. So what you're saying is we might not be doing it the best way, or are you saying we don't need it at all?
I am saying that there is a method and a technique to make concrete dense. And when you make concrete dense, water is unable to enter it. If water is unable to enter it, why do we need an air void structure in case water enters it to allow the water to expand? What I'm saying is that putting air in concrete reduces its life cycle. It makes it more permeable, more susceptible to chlorides and different CO2 attacks and all the things that happen with concrete to degrade it over time. I think air increases that. I think it reduces the life of it, because we're all studying this phenomenon of water going into the concrete and needing a room to expand and contract. It all goes back to the 666 test. Okay. So what I'm saying is, what if we took concrete and instead of putting air bubbles in it, what if we took as many air bubbles out as we could? All right. You're still going to have some entrapped air, right, as you're mixing in the drum. You're not going to really get rid of that. There's ways to defoam that and actually, knock the air out, but you're still going to have some entrapped air. So what if we made concrete slabs or pavement specifically so dense that water's not getting into it? I think that's just a new way of maybe thinking about it. And we're not new in this. I'm not an inventor of, no air exterior pavement, right? This has been done before. It's just not done enough. I think it needs to be done more. I think the industry needs to say, yeah, we can make concrete more dense and remove air, not put it in, but just not add that surfactant to the concrete, right? Yes, it's going to have some entrapped air, 2 to 3%, 1.5 to 3, somewhere in that range. But we want to have really good place and finishing techniques, and we want to cure it a proper way, right? I think this really comes down to, for me and my focus, it's exterior pavements, right? You could talk about air void structure and all types of other scenarios, structural, below ground, pavements, interior slabs, whatever. But I'm focused on the exterior pavements side of things. And I'm just really focused on maybe the structural side as well. If there's water containment structures or, below ground impermeable structures, those are also a good opportunity to, create dense concrete and not put that air void structure into it.
So do we need to replace, when you do a mixed design, the air is part of that design, correct? You calculate, we talked about that. I can't remember which episode it was, but we did a couple episodes on going through how to do your own mixed design. So are you advocating to replace that, or are you just upping the other ingredients of concrete to make it more dense, to take that amount of air out of the concrete?
Yeah, I'm saying don't design with it. Our process has always been better aggregate packing, better density through optimized and refined mix designs. We've always done that. So that's certainly encouraged. What I'm saying is don't account for the air. I'm saying don't put it in the mix. I'm saying don't calculate for it. I'm saying make a really dense, durable mix design, cure it properly. Fibers are great, and make water really work hard to get inside of it, right?
Yeah.
Increase the PSI. This is another thing. You start to study some of the pending litigation that's out there. I'm gonna hit a nerve with this one, but there's pending litigation out there over air. Why? It shouldn't be. Air is so tough to control from a ready mix producer standpoint. If you're finishing the top of that slab or pavement at all with over 4.5%, 5% of air in it, you're asking for a problem. I know an owner, this boggled my mind. I visited this particular project in the Northeast, and they were putting air entrainment in their exterior paving, I don't know, 6 or 7% air, and then they were trowel finishing it. Yeah.
Which, for the listeners, that's a big no-no. Then if it's
Yes.
Yes.
That's a big no-no. And when I tell you it was trowel finished, it wasn't even broomed later. It was trowel finished, and it was outside.
And
So,
Jason,
yep.
can you educate us why you don't trowel finish an air-entrained mix?
Happy to. Trowel finishing is sealing the surface. It is closing up the surface. You have a steel-bladed machine, whether that's through a pan, a combo blade, a finishing blade, whatever blade you're using, sometimes plastic, but you're closing the surface up through pressing that machine down on the surface. It has weight to it, density, and it's closing that surface up, right? So that's what I mean as far as trowel finishing a slab, for those that don't know. For those that do know, I apologize. So when you do that, you're trying to close the surface up. Well, air is trying to do the opposite. The air void structure is trying to keep things permeable and open. Well, you're trying to close it. So it's well documented. You can AI this, Google it, whatever, and search, and you're going to find that trowel finishing or finishing a slab outside or inside with 4.5%, 5% air and up, you are going to experience delamination and peeling and all the problems with that technique. You're going to experience that.
Okay, sorry to derail you. So back to your story. Northeast project has 6 to 7% air in it, and continue. Sorry.
Yeah, no, all good. They were trowel finishing it. And when I mean, I've seen people, and we've done this technique, but we don't put air in the concrete. We don't entrain or, air into the concrete. So we finish the concrete to give it more durability, to increase abrasion resistance. We have our own techniques to do that. These folks were actually just troweling it because I guess the owner liked that finish. But higher content, no brooming texture outside, Northeast, you could imagine they're having some issues with it. So I don't think many people are going to go to that extreme, and they certainly are shaking their heads going, we don't ever do that. That's great. I tell you, don't do that. But I think the phase that I'm in and concept that we've already proven, because these slabs have been on the ground for over 4 years, the ones I'm talking about, in Iowa, Kansas, Missouri, to name a few, and they're performing very, very well. And we did not entrain air into them. So I come, to the podcast just to tell the industry, hey guys, air can be an issue, and it can be a bear. And, I think if we'll maybe rethink, mix designs and play some finishing techniques and curing, and just create really, really dense concrete, and stop being afraid of that 666 test that exists. Maybe there's a better way to create longer lasting pavements out there.
Yeah. Yeah. And then it'd be one less test to argue about with the third party inspector as well. So that's always right. An issue. Less trucks turned away. And so before people go out there and just say, Jason Adams says, I don't need air in my concrete anymore. There's got to be a trade-off here. So what's the trade-off that we're doing if we're not doing an air entrainment?
Yeah,
additive. I'm sorry.
Yeah, no, it's all good. There's all kinds of pluses here, man.
I know there's pluses, but there's got to be a trade-off. So
yeah,
and the first thing that pops in my head would be, I would say it's going to be a little bit more expensive on the front end.
So
is that a fair statement?
I don't know. I think that's the listeners should chime in and maybe add some comments, right?
Yeah.
You have to buy air entrainment, and you get 5 to 6% less concrete, right?
Yeah. Well, air entrainment is not very expensive.
Yeah, I agree.
It's not expensive to put in. It's not like the producers out there are making a fortune on air entrainment and mixture.
Right. But you are getting less concrete. So.
You are getting less concrete. Yeah. I could insert a joke for our cement friends out there about getting less concrete, but I won't. So what is something to consider if you're looking at non-air entrained mix for an exterior application pavement?
Well, first and foremost, people are going to push back, right? I mean, that's a negative there. I'm used to that. I'm used to taking arrows. So, and I can take more, by the way. It's people are going to push back. They're just going to say, nope, we've been speccing air for this project or for this area of the country for the past 30, 40 years. Not doing that. So that's part of it. They're going to push back. There's sometimes you can get better workability with some air entrainment. Usually the concrete, can flow and finish a little bit easier. That varies, of course. Your mileage may vary, right? But so you may have to add a mid-range or a high range, to get that workability back. But we're used to doing that anyways with our system. So we're okay with that. Yeah, and it's just a little bit different. So you probably, like when we've done some of this in some of the Midwest states, the finishing technique may change a little bit, right? We may want to introduce a power trowel, a ride-on, and a broom. And that's a little bit different for some folks that aren't used to that, right? But they get used to it pretty quick. And the results for the owner are outstanding. Like I said, we've seen this 3 and 4 years later. It's like the surface is very, very durable. And you're seeing de-icing salts and brines and steel track machines and all the things for years. And the surface is holding up great. So yeah, it's a different way of doing things. But I think the logic is if the listeners can just get their head wrapped around this, concrete is a rigid, porous sponge, but you can make it closer to quartz. You can make it more dense. And if you make it more dense, you're able to do this.
Yeah. I was going to just jump in, and Trump was talking about marble versus granite. He went on a thing about the other day. So, marble is porous and granite is not porous. So he was saying how granite is just to bring Trump in here to get maybe, the algorithms, algos out there. We'll jump out there and say, Concrete Logic Podcast talked about President Trump. But anyways, so you're making it more dense. And we've talked about this on numerous episodes about protecting the surface of the concrete. That's the first guard. That's the first thing you want to, maybe spend a little bit more of your resources on, because that is the gateway to having problems down the road, right? So if you don't protect the surface of the concrete and things get in there, and once it's in the concrete, it's in there. So logically that makes sense to me, Jason. And we're not, this wouldn't be the first time where we've gone against the norm as far as ASTM and ACI standards out there. I've had Dr. Seichi on here a couple times, and we were talking about how the 90-minute rule is kind of ridiculous. So there are some standards out there that I think, and that's kind of the purpose of this podcast, is give folks a platform to challenge those things, because you're definitely not going to go on to an ACI podcast and challenge an ACI standard. At least I've never heard or seen that before. So yeah, that's an interesting approach. It sounds like once you get past the hurdle of an engineer accepting that there's a different way of approaching an exterior pavement with no air entrainment, and it's educating your finisher on maybe a different approach in finishing. But excuse me, as far as the timing of getting on the slab, is there any difference there as well?
We haven't seen that, Seth. I think it just boils down to all the other elements that control set time and finishing. No, I think the environment, the temperature, all the things that do really control set, we haven't seen it really change as far as taking air entrainment out. So, yeah.
All right. Well, did we cover everything on air entrainment that you wanted to talk about today?
Yeah, I think so. I think I want to keep it simple. I do want to say to the listeners that, may be thinking about this or may say, yeah, I want to try that. We've approached it as a system. So I am not saying that you can just take your standard 4,000 mixes on that has air entrainment and just yank the air out and go put it down. I'm not saying that. What I'm saying is that there's a way to create very dense concrete through optimized mix designs, through finishing, through nanotechnologies, through curing. Fibers help too, and pull all that together as a system to address the root problem, or create a material that's less dense. So I'm not encouraging, like you said earlier, I'm not saying, to the industry, run out and take your air out, screw that air, right? I'm saying that, let's rethink it, because we're proving it and I love it. I don't want to put air in our slabs at all. Like, I want to kill every drop of air that I can. I want our paving and our slabs to last way longer than me and way longer than you and everyone else listening to this. So I want to keep the air out. So that's kind of what I'm here to say. But, be careful, tread lightly, right? And if you get scared back into the 666 test, maybe ask yourself why, right?
Yeah.
So,
well, cool. Well, if folks want to learn about that more, Jason, and what you're doing with your Mega Slab, what's the best way to reach out to you?
Yeah, that's thank you, Seth. A couple different ways. I mean, we've got the typical website, megaslab.com. We've got a contact, link in the box you can just fill out. You can email us at info@megaslab.com. We'll get right back to you. And yeah, just look forward to seeing the industry progress forward overall. I think, ready mix producers, you guys at Baker, the various, awesome concrete subcontractors and design build firms that self-perform, like all the folks that we're collaborating with. I just want to see the industry get better. Whether they call us or not, it's okay. I want to see the industry get better and the material last longer. And let's leave something behind that's way better than how we found it.
Yeah. Yeah, that's an awesome way to end today. Jason, thank you for coming on the show today.
Absolutely.
Appreciate it. And folks, until next time, let's keep it concrete.
Thanks for joining us for another episode of the Concrete Logic Podcast. If you got value from the show, here's how you can provide value back to support the show. Visit concretelogicpodcast.com and click the donate button to send value back. All dollar amounts are truly appreciated. And now, to close out the show, here's Mike Dunton.
Ring, ring, that alarm always sings. Couple hours before the sun comes up. Open up the side, put some diesel in the lights, and wait till the trucks roll up. Yeah, this ain't how most folks live their lives. Dripping in sweat, working overtime. But while they're tying their ties for their 9 to 5s, we're out here changing these skylines with wood, iron, and mud. We work hard for $1, give thanks to the Lord above. Never make a man do something you can't prove. Hard work calls for a drink or two. Expect more, it's written in our blood. With wood, iron, and mud. From the swamps to the city, from the Lone Star heat to the woods of the Georgia pine. The good old boys and girls who ain't afraid of getting dirty for a clean time. And if you want to see the fire in a grown man's eyes beneath the hot summer sun, find the wild-eyed boys clocking days and nights, working hard to get that job done with wood, iron, and mud. We work hard for $1, give thanks to the Lord above. The color of our collars ain't white or blue. We're all gray collar through and through. Expect more, it's written in our blood. With wood, iron, and mud. With wood, iron, and mud. We work hard for $1, give thanks to the Lord above. Never make a man do something you can't prove.